Okay guys, so today we're looking at symmetry, okay? And symmetry basically comes in two forms. We have rotational symmetry and we have line symmetry, and they're two different things. Basically what you're going to need to do today is you're going to need to be able to state the rotational symmetry of shapes and also the line symmetry of shapes, okay? So let's start off with this rotational symmetry. And basically what rotational symmetry means is if you have a shape and you start in a position and you turn it 360 degrees, you look for how many times it looks exactly like it did when it started, okay? So if we had something like a circle, it would have an infinite number of rotational symmetries because it always looks exactly the same, okay? With a square, if we start turning it, it's going to look like, let's just say, if we turn it and it goes from this becomes the bottom, okay, that's 1, okay, and then we turn it again, that's 2, and then we turn it again, that's 3, and then we turn it back to its original position, it's 4. So this shape's rotational symmetry would be 4. Now, that's an important point, how I said that once we get back to the beginning, we also count it as 1. So that means that if something has no rotational symmetry, okay, it has a rotational symmetry that is equal to 1, okay? And when we jump down here to this equilateral triangle, that's the result that we're going to get, okay? Now, if we have a look at the line symmetry is probably something that you're familiar with and you've used it before, okay? Line symmetry is basically when we draw a line through a shape, okay, and we can fold it over to make the same shape. It's equal on both sides. So basically all we do is we just draw lines through shapes and we see if we have line symmetry. So with a square, we have 1, 2, 3 line symmetries with this one, okay? So we have 3 lots of line symmetry with our square, okay? I know that it comes out here at 1, 2, 3, 4, 5, 6, 7, 8. Oops, I've missed one. 1, 2, 3, 4. It's got a line symmetry of 4. And I know that it comes out at 8 different points, but we look at the individual lines, okay? So if we jump down here to our triangle, this isn't an equilateral triangle, it's an isosceles triangle. So that means that these two sides are of the same length. We can have one line symmetry like that, and that's it. So it would have a line symmetry of 1, okay? But when we come to rotational symmetry, if we rotate this, no, it's not going to look the same. Definitely not going to look the same when it's standing on top of its head there. And when we turn it again, it's going to look like it did on that other side, so it's not going to look the same. And then we get back here to the start where it finally looks the same again. So we would say that this has a rotational symmetry of 1, okay? So when you have a shape that's a funny looking shape, you know, you could have a shape that looks like this, okay? And you could flip it around 360 degrees and it wouldn't look the same at all until it gets back to the beginning. We would say it has a rotational symmetry of 1. So if there is no rotational symmetry, it has a rotational symmetry of 1, okay? Shapes can absolutely have no line symmetry as well. There's no way I could put a line through this and make it look the same. Doesn't matter which way I go, which direction, it's not going to look the same, okay, on either sides of that mirror image, okay? That's about it, guys. That covers everything that we'll be doing in symmetry. Good luck with that. Make sure you ask your teachers if you have any questions.